Thank you for joining this lesson. We're going to continue with the Maranda High School mock, Mathematics Paper 2, number 14, a question from Vector 2, Collinearity. We are told that the position vectors of R, S, and T are as shown. We have R, S, then T. Show that R, S, and T are collinear points. Remember to subscribe to the channel and to also share the link with friends. So what we shall do, we're going to find any two vectors, then we express one as a scalar multiple of the other. So we can, for example, take vector RT, which will mean we will take OT minus OR. And this is going to be OT, which is 4, negative 1.5, and 2. Just getting the coefficients of the column vectors, and OR 3, negative 1, negative 1, this is plus 1.5. And this vector is going to be, one, then negative 1.5 plus 1, because this is minus minus, plus 1 will give us negative 0.5. Then finally we have 2 minus 1.5, which is 0.5. So now we have vector RT. We can also get another vector like RS. Vector RS, which will be given by OS minus OR. Then OS equals to 6, negative 2.5, 3, minus OR, which is 3, negative 1 and 1.5. Then now we come up with the difference. This is going to be 3. This is going to be negative 2.5. This is plus. We'll get negative 1.5. Then 3 minus 1.5, we get 1.5. So now we have two vectors here, and we're going to express them in terms of the other. If we assume RS equals to a certain scalar multiple, call it K, multiplied by vector RT, then we can get this scalar multiple, whereby RS, which is here, 3, negative 1.5, 1.5, will be equal to K multiplied by RT, which is 1, 0.5. Remember, this is negative, and 0.5 positive. So now we can get the value of K. If 3 equals to K, then we can say 3 equals to K. We confirm using the Y components. 1.5 negative equals to negative 0.5 K. So when we divide through the 0.5 negative, the negatives will cancel, and K is confirmed to be 3. Then we can see again that 0.5 K equals to 1.5 will also give us K as 3. Therefore, we can say the vector RS equals to 3 multiplied by RT. So this vector is a scalar multiple of the other, which means vectors RS is parallel to RT. So to show collinearity, we need to prove that two vectors are parallel, and we have proved these ones are parallel. To show that vectors are parallel, you show that they have, one is a scalar multiple of the other. And again, because they are parallel, and we have a common point, which is R. R is a common point. Then we can say now these 3 points are collinear, since we have shown there is a common point in two vectors, and such vectors are parallel to one another since they have a scalar multiple. Thank you for following. Subscribe and share.